We are doing a secure installation of ArchLinux. Let's go. You will need a laptop, a USB pen drive, and in my case an external networking card. Secure install means encrypting your hard drive, generating the unified kernel image and signing it for SecureBoot. Grab yourself an ArchLinux ISO from their website, and if you are on Windows, use Rufus to copy that to your USB pen drive. If it asks you, use the DD mode. For now, disable the SecureBoot, and while we are in BIOS, find the option responsible for enabling your own key enrollment. Boot your installation media and start the installer. Before we begin, all of the instructions are also available in my GitHub repository, link in the video description. First, check your blocked devices with LSBLK. Then, wipe the partition table by overwriting it with zeros. You can use DD for that. Press Ctrl+C immediately after. We only need to overwrite few first megabytes. Use gdisk for partitioning. Create a blank GPT partition table. Create 512 megabytes EFI partition. The code for the EFI partition is EF00. Assign the remaining space to the other partition. Give it code 8309 or the Linux looks encrypted. Create FAT32 file system for your EFI partition. Format your second partition with crypt setup. Using crypt setup, open your encrypted partition and assign it a name, in our case cryptlvm. Then we can proceed to the LVM provisioning. First, create a physical volume and point it to our cryptlvm. Then, create a volume group and also point it to our cryptlvm. Finally, create a root logical volume under our VG group. Create a file system on your root partition. In this case, I'm using ext4. Mount your root partition under /mnt. Then, within your /mnt, create boot and EFI directories. Mount your EFI partition to the /mnt boot EFI. Now we are going to install our operating system. We can do that with the backstrap command. We point it to a location, in this case /mnt, and then give it a list of packages to install with the system. I'm choosing base system, firmware, CPU microcode. You should choose Intel or AMD appropriately. Sudo vim lvm2, more utility packages, EWD for Wi-Fi, DHCP-CD to manage network auto configuration, and lastly, Broadcom WL for Wi-Fi drivers specific to this laptop. Now you know why I showed you the external networking card at the start of the video. When we hit enter, the backstrap will try to download all of the packages from the Arch repository servers. It's not a big deal if you forgot some package at this point, since you'll be able to install them in a moment. After backstrap is done, we have to generate our fstab. Gen fstab will do that for us. Now we can use the Arch root to switch to our newly bootstrapped system. Set the administrator password. I also suggest you install manuals by getting mandb package. That way, if you ever get lost or are unsure of something, you can read the manuals. Next, we can perform some local configuration. Set the local time by linking the appropriate file to the etc local time. For the locals, uncomment the ones you want within the local.gen file, and then set your preferred one in the locals.conf. Don't forget to generate your locals. For the keyboard, since I want to use Polish letters on mine, I have to tell the system to use certain fonts and keyboard layout. Finally, I am setting the hostname. Time to add some non-administrative users. Choose your username and in this case, create your home directory. For some reason, it doesn't auto-create even with explicit option for user add. Since we did that as root, we have to change the ownership of that home directory. I am also setting a password for my user. Now for the sudo configuration, use vsudo and uncomment the line with the wheel group. Save and quit. Then add our user to that group. As a final step before we reboot, I'm enabling some systemd services, so that EWD and DHCP will auto-start with the system. Our first script will take care of launching the Drucket command responsible for generating our unified kernel image. It will hook into Pacman and generate an image for each kernel version installed. But in practice, this will always be only one version. Another important thing is that I am saving the generated image to EFI boot bootx64.efi. This is done for compatibility reasons, since some UEFI firmwares can ignore EFI entries but still look for that file in that specific location. The script for removal is way shorter. We only need to remove our single bootx64.efi file. Make sure those scripts are executable. After that, we have to write actual Pacman hooks. We still need to provide Drucket with information on what command line parameters to use with our kernel. Notice how I get the UUID of the encrypted Lux partition, so I don't have to type it by hand. Kernel arguments include information about our Lux encrypted partition UUID, LVM, file system, and mounting options. Be careful not to make any typos here. Then, in a separate file, I declare flags for Drucket so that our unified kernel image is compressed and not generated in host-only mode. We can tell Pacman to reinstall the Linux package to make sure our hooks work and execute properly. If there's any issue, the log should point you to the problem. The next step is to generate UEFI boot entry. Since we're not using grub or anything similar, we can boot our kernel image directly from the BIOS. EFI Boot Manager by itself displays current state of boot list. You may want to remove leftover entries from Windows first, and then add your own. You can also modify boot order here, if you need more than one entry. Now we can quit the installer and boot to our system. If you haven't done so yet, you should enable setup mode for SecureBoot in your BIOS and erase your existing keys. It may spare you setting attributes for EFI vars in the operating system. Configuring SecureBoot is easy with the sbctl package. sbctl shows you the current state of SecureBoot. Generate your pair of signing keys and sign your unified kernel image. Tell the Drucket where those keys live, so it will automatically sign every generated image. Then, we add one last Pacman hook for sbctl and point it to our EFI file. Enroll your generated keys to the UEFI firmware. sbctl can also additionally add Microsoft keys if you want to dual boot. Reboot the system, enable SecureBoot, and set BIOS password. Without that last step, an attacker can just go into the BIOS and disable your SecureBoot. If everything went well, you should have to decrypt your hard drive first before you see the login screen. Verify with sbctl that everything is working fine and all the check marks are green. Now you're proud owner of a secure laptop running Arch. Even if someone were to take your computer, they can't enter BIOS, and they can't mess with your EFI partition, nor they can launch any live ISO, since SecureBoot will not run anything not signed by your deployed keys. Next time, I will show you how to install graphical user interface. Thank you, and if you made it to the end, please like and subscribe if you enjoyed this tutorial.